Hi everyone, so today we'll look at this question from RJC, 2020 H2 math paper. So it is a DE question by substitution. So for the first part, prove that for x more than 0, the substitution will reduce the DE from y and x to, in terms of u, and du dx. So you're given this and you're given a substitution. So for H2 math, right, the substitution is always given. So you keep in mind that in this case the u and the x are both unknowns. So when I proceed to differentiate it, so when you do this type of DE and the substitution, right, always differentiate your substitution. So keeping in mind that both u and x are not constants, right, so that means I must apply product rule. How to do that? Copy and then I'll differentiate x plus copy x, differentiate u with respect to x, so it is du dx. I just applied product rule. So after that, we're just gonna put it all in. So y, if we manipulate the substitution, right, so y is actually equal to ux minus x. Then dy dx will be u plus x du dx. Then you see the minus y over x, right, is actually a minus u. Then we'll over here we'll get a u square x square plus 2x squared. So do you see over here, we can simplify it further. So it's ux minus x times x du dx, equals to u square x square plus 2x squared. So the goal here is that, you will realize that the final product here does not have x at all. So let's see how we can get rid of it. Maybe we'll do an expansion over here to get u x squared du dx minus x squared du dx. Then over here there's no change. So over here we can factorize out the x squared. So all the x squared will disappear. Factorize and divide away. So now I'm left with du dx, u squared plus 2. Then what I'll do is that I'll factorize out my du dx. It's a common term here to get u minus 1, u squared plus 2. Then the question wants it such that it is du dx. The right hand side equals to 1, right? So we will divide by u squared plus 2 to get 1. Over here we'll also divide by u squared plus 2 to get 1. So it will be du dx times u minus 1 over u squared plus 2 equals to 1. Then after that, I'll just split up the fraction. So I'll get u over u squared plus 2 minus away 1 over u squared plus 2 du dx. And this is what we're looking for. So proven. So for part 2, we want to find the general solution of this DE. So we've reduced it to this already. So then for H2 math, DE is somewhat easier because we can only solve DEs using separable variables. So from what we have previously, we can just integrate both sides with respect to x. So what I mean is that I'll integrate both sides with respect to x. So in the end, I'll just end up with integrating this with respect to u and integrating this with respect to u. Then on the right hand side, we are integrating with respect to x. This is what we call separable variables. So from here, how are we going to integrate this? So this is looking like integrating f prime x over f of x dx to get our ln f of x plus c. So we're going to use this one for this one. Then over here, we can look at our mf26, right? When we integrate 1 over 1 plus x squared dx, I will get tangent inverse x plus c. So we'll keep that in mind. okay, when we integrate these two. And of course I don't need to teach you how to integrate 1. Okay, so for the first one, okay, in order to do that, the top must be 2u, okay, u squared plus 2 du, but I cannot change the expression, so it become half over on the outside. Over here, I'll just change this 2 into a form that's easy to see, which is root 2, okay. So now we are very clear on how we can integrate this. We just need to apply formula. Okay, so if I integrate, it will be half ln u squared plus 2, okay, don't forget your modulus. Then over here, it will be a minus 1 over square root 2 tangent inverse x over a. Okay, then equals to x plus c. Okay, but we want the general solution in terms of x and y, so I will then need to replace all my u with x and y. So u actually equals to y over x, so I will now replace all my u's to become y over x. So this will become y squared over x squared plus 2 minus 1 over root 2 tangent inverse u is y over x, so it will be y over root 2x equals to x then plus c. Okay, so the general solution will just be in terms of x, so I will say x will then equal to half ln y squared over x squared plus 2, close the modulus, then minus away 1 over root 2 tangent inverse y over root 2x. Okay, then it will still be plus c. Okay, because this c is an arbitrary constant, so it doesn't matter whether it's a minus or a plus. So in general, we just put it as a plus. Okay, and this is how you solve question 3 on DE for this paper.